So from the security perspective and even like how now the AI is writing code.
In the age of AI, clearly, if every time you change a policy, you have to update all your applications, that whole loop becomes very slow. It led to something that we now know of as the OODA Loop, AI governance, because that's a big pain point with enterprises everywhere.
Interesting thing which we see is you chose those native Kubernetes custom resource, which famously being called as CRDs.
Kubernetes gives us a standard way, no matter what you're designing for.
If I'm right, Kyverno relies heavily on validating the webhook.
It's a highly optimized, high performance, high throughput type of engine for matching and then executing policy pipelines.
Today's developer are mostly using the Gen AI assistance tools such as Cloud Code, Cursor.
There's a lot of risk on privacy, data leakage, there's a risk on token costs. Whether you're writing code with AI or you're building applications which are using AI, governance has become super important.
Yes, security is fine if I just cut down every access, then I'm 100% secure, but it is of no use for me.
Governance and policy as code, and these topics might seem a bit complex or daunting, but they're not.
Hey everyone, welcome back to another episode of Techie Talks with Kuldeep. I am your host Kuldeep Singh. Today we are excited to have another industry veteran with us, Mr. Jim. Jim is currently founder and CEO of Nirmata. Jim, welcome to the show.
Thank you, Kuldeep, and thanks everybody who's listening.
Okay. So, Jim, before we start our interesting conversation on AI governance via policy as code and deep dive into the technical topic, if you could describe about your experiences and journey in the IT industry so far.
Absolutely. Yeah, so my background is in software development, still pretty hands-on with systems and coding and different infrastructure types. I'm originally from Mumbai, from Bombay, and but came to the US. This was back in the late 80s. So studied over here, worked in the telecom industry in the 80s and 90s, and then moved out to the San Francisco Bay Area, in the late 90s, early 2000s, and I've worked in several startups, several big companies in various engineering leadership type role before. And we started Nirmata about almost 10 plus years ago, initially as a consulting company doing microservices, containers on the infrastructure side, and then shifting into policy and governance on the Kubernetes as well as cloud native and now agentic ecosystem.
No, I think that's like a big change, right? Working with those systems engineering and then still keeping yourself hands-on was a good one, although you have changed your role. But I think even by looking at the changes, how they are coming, I think being a hands-on is still the great thing.
Absolutely. It's a lot of fun, and there's no better time to be building. So always excited about that.
Okay, so from the security perspective and even like how now the AI is writing code, I know maybe 6 years or 10 years back, we moved more from managing those security needs via infrastructure as a code, and that became our standard. But in today's world, when there is like more and more AI workload specifically hitting the cluster, seems like the static pre-deployment check which we used to do are not enough. But that also bring a very interesting point. Is hey, is it still the decoupling policy from the application code and moving it to more dynamic and runtime is a requirement for the enterprises nowadays?
Yeah, no, super interesting question and topic, right? So something I think about also, and when it comes to not just policy and governance, but system engineering in general, is this paper that was published. This was back in the 50s and 60s, before our time, but it was initially a research paper from the U.S. Air Force, and there was a colonel called John Boyd who published this paper on what makes certain decisions faster, and this was for fighter jet pilots, right? And it led to something that we now know of as the OODA Loop, which describes different phases in a decision making process. And the phases he outlined were, in any system you need to first observe, so that's the first O in OODA. Then you need to orient, Then you need to decide, and then you need to act. And these four steps, if you kind of think about it, over the decades, over the years, we, still follow these four steps, but the loop has become tighter and tighter and faster, right? So Kubernetes with the controller pattern really codifies the OODA loop. Controllers in Kubernetes, they will observe different parameters, metrics, they will orient, they will decide by collecting data from different systems. Then there's a static decision engine, and then there's some action that's taken, right? Now, going back to your question on policy as code and governance and why does this matter in the age of AI? Clearly, if every time you change a policy, you have to update all your applications, that whole loop becomes very slow, right? You're not going to want to do that in your system. So you need to decouple policies from applications. And the second thing, as part of it, is you need this dynamic two-layer system, right? So you need a very strong and deterministic enforcement layer, which is what Kyverno, our open source project, which Nirmata created, donated to CNCF, that acts as the enforcement layer. But then you need a decision system on top of it that's doing that observe, orient, and decide part of it before the action can be given off to Kyverno, right? And that's the brains we're building at Nirmata, originally for Kubernetes and infrastructure governance, but now more and more for AI governance, because that's a big pain point with enterprises everywhere.
No, you are right. I think, specifically with the microservices architecture, right? So where we wanted to have the decoupling of the infrastructure as well. I think this policy also, makes sense so that you can separately deploy your policy and test your policy. It might not be even nowadays like your application code might have caused that issue. Maybe, certain policies, for example, even with the AI, we see, right, hey, certain models were supposed to disable for a specific location, etc. If you would have embedded it into like in an application code, you would not have been able to achieve it.
Absolutely.
Yeah. And one very interesting thing which you mentioned is like, hey, of course you have built this company, but also you contributed it into the open source, right? And this open source contribution, which is available as part of the CNCF, one interesting thing which we see is you chose those native Kubernetes custom resource, which famously being called as CRDs. Although, like many people who are a deep, Kubernetes expert would love because then they know where they need to change the configuration and make it working. But is it still better from the scaling within the enterprise perspective, or do you think a specific domain specific setup would be more useful for them?
Yeah, it's always tempting, especially for us who are engineers or software developers. We love DSLs and domain specific languages, right? Because it's fun to kind of tinker around and create something new. And what Kubernetes did, which was brilliant, was they gave us a structure for creating APIs and creating DSLs, and then decoupling them from the controller logic, like we talked about with the decision making, et cetera, right? So if you think about, you mentioned CRDs or custom resource definitions, that's the API part of it, right? Kubernetes gives us a standard way, no matter what you're designing for, right? So if you're designing for running pods, or now Kubernetes can also be used for other things. It gives you also something called a KRM, or a Kubernetes resource model, which means that every resource behaves in some structured way. So now, as we are writing new controllers, yes, I mean, of course, you can create your own DSL, you can create things, but more and more, what's happening is even people who are creating DSLs, they're translating it to Kubernetes resource models and then executing controllers in that, right? So it's become that infrastructure layer that's really powerful for declarative APIs and other things. Now, like you mentioned, when we created Kyverno, and there were other tools that already existed, notably like Open Policy Agent was very popular already. they have proved the use case for policy as code. And people, when we spoke to customers, when we spoke to the community, they said, look, we love the idea of policy as code. We love, declarative policies, but the language Drago is just super complex, right? And it's hard for us to, scale that. It's hard for us to understand that. So what we thought about, and it always comes back to whether you're building a business or a software, product, you have to think about who's your user, right? Who are we building this for? And the answer for us is for a Kubernetes admin. So we started, cataloging, okay, what does the Kubernetes admin already know? And if they know Kubernetes, they have spent time and effort to learn about Kubernetes. And today, like, by the way, one of the statistics from CNCF is almost like 20 to 25% of, developers worldwide are certified in Kubernetes, which is mind boggling, right? It's a big percentage of developers, and that will only continue to grow. So as Kubernetes becomes that de facto sort of operating system for cloud native systems and for AI systems in the future, more and more people will learn Kubernetes. So our thinking was then why not make it very familiar to them? Why invent something completely different, completely new? And why? How can we kind of make this familiar, but still extensible and still very capable of delivering complex use cases? That's why we chose CRDs. And a recent decision we also made is, initially Kyverno was using a logic processing, a JSON logic language called JamesPath. But Kubernetes internally has adopted something called Common Expressions Language, or CEL, which is, something that can be compiled, sandbox. It provides very fast, secure execution. So Kyverno is also migrated to CEL. So we have restructured our policy types, to match what Kubernetes again already uses in several different layers, and we have standardized on CEL. So again, to make that learning curve, the adoption curve, very familiar and straightforward, as well as provide the full declarative, power of declarative interfaces, power of decoupling controllers, and all of the strengths of Kubernetes that it provides out of the box.
No, you rightly said on the statistics part, right? So most of the people who are managing, whether it is in the vanilla Kubernetes or in the services-based Kubernetes, they are certified, which means they know in and out how does it work. So probably for them, even if they need to change certain configuration, they will be more comfortable in doing it. And as you said, right, so the application, of course, you might have chosen a different language, put it there and all, but just think it when you think it from the hey, his administrative perspective, he needs to like learn a new thing and all, and that might have even resisted in the adoption. So that's I think very good architecture decision which you took there.
Thank you. Yeah, and it certainly paid off because we see that being one of the main factors why people start with Kyverno, but then there's many other features that it does, like in the full resource lifecycle management, where people stay and continue to use it as a toolbox.
If I'm right, Kyverno relies heavily on validating, the webhooks, right? And mutation is powerful for when you are using, the sidecar architecture, but they also becomes problematic, right? For example, if they introduce, the API latency, and if there are any cluster failures at all, the timeout becomes, the major problem. So how does within the current implementation method you handle it's just to make sure your throughput you are getting, but you are also not impacted by those cluster or the API failures?
Absolutely. Yeah. So as you said, Kyverno sits in the admission controller path, right? So that means anytime there's a change in the cluster, anytime there's an API request that goes to Kubernetes, whether somebody is doing an exec into a pod or whether somebody's creating a new pod, all of those changes are intercepted by Kyverno and policies can be applied, right? So over time, Kyverno is now like 6 to 7 years old. It has been battle tested. There's a lot of battle scars along the way, lessons learned, things we got wrong and we have improved. but it's a highly optimized, high performance, high throughput type of engine for matching and then executing policy pipelines, right? And like I mentioned, now with this migration to Cell, we even saw further improvement of performance because Cell policies can be fully compiled, they're sandboxed, they can be cached in memory. So it's very low latency in terms of the overall execution. And the way this works is not all policies. So if you have 50 policies, 100 policies, or 200 policies, I even met somebody at KubeCon where they said they had over 1,000 policies, which is like, okay, that seems like a lot. Like, well, how many, do you really need 1,000 policies? But in their system, in their environment, there was a need for it. So they were, like Kyverno still takes a few, microseconds or milliseconds for execution because not everything has to be, executed during admission controls, right? So first of all, there's a very highly tuned matching system which decides what policies have to be applied for every request. And then once that subset is picked, because policies are fast compiled sandbox, there's no interpretation, there's no extra data fetching at that point. We have other tools to fetch data, cache data. So the idea is you kind of make your memory in all of your execution in memory, and you are you of course you're trading off some memory for a better performance and lower CPU, right? So Kyverno is typically very performs very well, but it is a critical component. It needs to be monitored. So going back to even our OODA loop, story and analogy, that observe part is very important, right? You need to have observability built in. And Kyverno provides a lot of metrics, a lot of things. So if somebody writes a policy and it's non-optimal, you can catch that and test that in your test environments very quickly and learn how to improve it. And the good thing is with open source, with the strong community, there's hundreds of policy examples. There's many, kind of best practices published. So the community also keeps contributing back, and that makes the project even stronger.
So you are right, and with these community contributions, so it is like available for everyone, and I think people can just check look on those part, and if they need to like improve something and all, and I think they can also contribute it back. For example, if they suggest some changes, this is something which you can do. And I see like it's also been being very active into the, for example, into the KubeCon and the other community event where they can meet with the other people who have been using it and also can provide the feedback.
Absolutely. Yeah, it's very powerful from that perspective, and open source gives you those benefits.
So, like everyone else, we will also talk about AI. And if I'm correct, Nirmata also just introduced AI controls, right? Which means Kyverno will move directly into the AI runtime stream, and where we are also governing, the actual LLM API calls. But given, right, the today's developer, they are mostly using, the Gen AI assistance tools such as Claude Code, Cursor, or even like the other tool. Are they representing the entirely new methodology how we are developing, the code? Are they not introducing any significant risk for the enterprise infrastructure as well as for the data side?
There is a lot of risk, right? And that's where, there's a lot of also activity you see around AI governance. Yeah, the funny thing is, we were talking about governance at Nirmata for the last, almost like 4 or 5 years about infrastructure governance and Kubernetes. And the reason why even a system like Kubernetes requires governance is there's multiple roles, right? So there's developers, operators, as well as security teams, all interacting with the Kubernetes, system, right? And whenever there's multiple roles, no matter what we're doing in life, whether we're playing a sport or whether we're building a team, whenever multiple humans interact, you want to define some rules, right? If you're like, if you try to learn a new sport, the first thing you want to do is what are the rules of the game? What are the rules of engagement? How should we behave, right? Who should do what? What are the roles? And that's really what governance is, right? Governance is nothing different than defining those rules. Now, of course, in a digital system, those rules you want to codify and create as code. So that's where policy as code comes in. And then you want to apply those rules. So now going back to AI and AI engineering, you're absolutely right. There's a lot of risk on privacy, data leakage. There's a risk on token costs. Now there's a whole foundation created for tokenomics. So it's balancing, and there's also to me the bigger problem is also productivity, right? So are we all engineers doing the right thing? Are we sharing the right best practices? Are developers becoming good AI engineers, right? Because that's become a must have. So just like, if you think about back, when databases first emerged, maybe this was in the 70s, 80s, every developer had to learn how to use databases, right? Now LLMs have emerged. Every developer is going to have to know how to use LLMs, both for writing code and as part of their application stack, right? Because your app is going to be talking to an LLM for some of the AI related features. So in both cases, whether you're writing code with AI or you're building applications which are using AI, governance has become super important. And really, it's about defining the rules of engagement and then being able to observe, enforce, and being able to also, decide and act on top of them, right? So that's what we're looking at from AI controls. Just like Kubernetes has a well-defined admission controller pipeline, we're looking at the full request lifecycle with AI engines, whether it's an LLM request, an MCP request, or even an A2A call, and being able to apply different rules to it that the organization can decide. Now, out of the box in AI controls, we have almost like 60 plus different rules you can pick and choose from, different policies. All of this is, by the way, also powered by the same Kyverno policy engine, which has been, like we said, tested, matured, and is highly optimized, over time. And we're able to now take that and apply that in a completely different layer, which is the protocol layer for AI, as well as, keep the admission controls and, some of the runtime checks, which Kyverno already does. So now if you think about, people talk about zero trust for AI agents, Kyverno can uniquely provide that by covering all layers. Otherwise, you have different systems, different reporting, different exception management, which is a nightmare and a big mess to manage.
No, you are right. And it's like, chicken and egg problem, right? To secure something, you need to, get, some data or some output, which you can analyze and make sure, right? Hey, there are these security and, the controls which we have applied are useful. But this also introduces one thing. And I know like with the Gen AI assistants, people are expected to even work faster, which means to create, those artifacts even faster. But doesn't it create some sort of a latency? Because even if I'm just going today, right? Even via connecting with these multiple MCP servers and all, there is always a time it takes. It gives me the output, etc. But if you just add these layers, wouldn't be a significant latency addition on those?
There is some latency, right? But it's typically, again, microseconds in terms of execution. And we're only, just like we've optimized in the Kubernetes, request processing, API processing pipeline, it's the same techniques, the same approach we're using to build an AI processing pipeline, right? So each request, has some pre-flight checks where you make your key decisions for like routing, for model selection, things like that. Then you come down to like other checks that you're doing in terms of like whether you're validating that actual request to make sure that it can be allowed or denied. Before that, you can mutate the request. So even if you want to change things, like have budgets, have provide exceptions, and then finally there's a dispatch phase, right? So we've built the system in a manner where it's again high performance, high throughput, but can apply those checks. Now, if you look at a request lifecycle in AI, the bulk of the time goes to the model, right? Which is where it rightly belongs. So that, few microseconds or milliseconds at the most of latency that it's not even noticeable that you're going through AI controls. Much like in Kubernetes, nobody thinks about the API server. It's there, it does its job, or like Kyverno does its job. You only think about it when there's a problem or something is not tuned or not working. But those are the sort of challenges, the hard problems that we're solving, so that people just can forget about this and do their work and move fast in a secure manner.
Or you are right, and that might be like where you have already put, the efforts while architecting this, which means like it could scale well. And the API part was in it. Like, for example, if I'm requesting, I'm able to run those custom resources, and if the cluster health is fine, of course you can't really go ahead and fix the cluster health. That's where you still need to be dependent on the Kubernetes admin. But as long as the clusters are healthy and these kind of the calls are not like there is no kind of the external. For example, it should not happen. The model wherever it is running, that site itself is down. That is something uncontrollable. But as long as those bits and pieces are on place, you are just doing a webhook, pulling those things and just making the decision right away, and then giving it back whether this is a legitimate call or if it is like someone has might be introduced something in it.
Absolutely. Yeah, and this middle layer, and like in our industry, we always have built middleware, right? So this is the new form of middleware for AI governance. Can also do some smart things like optimize caching, compression, routing, which actually speeds up the request, right? So and it lowers the token costs. So it's a win-win if you look at whether you're an administrator, whether you're a developer. There's no reason why you would not want to use this because it provides so much value overall across security, cost management, budgeting, visibility, and other things, which would just be impossible to do otherwise.
And one more pattern which we see is also specifically with the engineering team, right? So engineering teams are more or less the distributed in nature, but there is still a central security teams which guide them or advise them or even sometimes write those policy. How does these team which really works in the distributed fashion can make sure, right, these guardrail checks are not becoming like a too much restricted? Because yes, security is fine if I just cut down every access, then I'm 100% secure, but it is of no use for me.
Right. Now you're absolutely right, and that's a good point. Doing nothing is very secure, right? So because you're not making any changes, so of course it continues to stay secure. But obviously, no business wants that where developers are sitting around doing nothing, right? You want to be pushing code, you want to be creating features, you want to be making changes, right? Because that's what drives velocity, that's what drives productivity and other things. Yeah, so the balance here is, policy as code needs to be understandable, not just by security teams and accessible to security, but to developers too. Look, as developers, every developer understands the need for security. But when it becomes a chore or when it becomes a burden, they will put it off, right? So they will say, hey, I don't have time for this. I just need to get my application out and done. And what developers and maybe in general us as humans, when we're in the middle of something, when you're in that productivity zone, you don't want to stop and then talk to security and create a ticket and wait a week. You just want to get your stuff done, right? So what we have done with Kyverno and now we're building into AI controls is that self-service empowerment for developers and for others, right? Just as a simple example, like if let's say in your prompt that you're sending to an AI, there's something that looks like, data which might be sensitive, like a social security number or a credit card number. Now you could, just block that. But maybe the developer was testing their code and they're using some fake, data, right? So you don't know that as a security team. So if you just block things, naively, they're like, hey, I can't even test my app. How am I going to get my feature done? Right. So those sort of things, your system has to be intelligent enough. And secondly, it has to allow that flexibility to warn the developer, but let them in a self-service manner say, yes, this is safe, and I'm going to vouch for that, right? So in even in the security and vulnerability management, there's a way now where if there's a vulnerability, you could say, what is the impact of this vulnerability to my system? And who better to gauge that than the developer, right? So putting that, that responsibility on the developer, but letting them make that quick decision and say, yes, this is safe. I'm vouching for it. Here's why it's safe, and I give me an exception, right? And you move on. You don't have to talk to anybody. You don't have to, and the system is recording that decision, capturing the information. So later, if needed security, you can go analyze that, can inspect that. There's all these tools and power available, but you did not block the developer from doing their work, which is extremely important.
Yeah, and that's where the culture comes as the main part of these processes or the changes, because still you can codify too many things, but if you can work on the process side and work on a cultural side, because even though like you might be representing two different teams or the verticals, still you are working for the company to move faster, right? So that we can release this software to the users and get the feedback quickly.
Absolutely.
Okay. I know we touched on some longer question, and now we will just move to the rapid fire style. And let me start with first. And I think because since you are still coding, right, you might give the answer. So like there are three main. There are more, but
Yeah.
at least whenever you search, it's like Go, Java, or JavaScript. If you have to write only in one language, like for next 5 years, which one it will be?
Today, Golang. I've used all three in the past. I've built systems and all. Each one has its, of course, trade-offs, but Golang has a really good balance of power, flexibility, and it's also designed for teams, right? Which is something unique about Golang. It's the first language which kind of takes that approach to just build in the best practices with Java and JavaScript and others. There's too much flexibility, too much kind of, things that you could do wrong. And Golang takes away a lot of that and lets you focus on what's important, which is building and delivering systems.
Yeah, and given the nature of how the core language came was on for the specifically for the distributed systems, right? So it do have those inherited features and the qualities. Okay. Second question is typically, yes, people do have, the experience once they start using it. But what are, one or two configuration mistake which the teams make when they first spin up Kyverno in production system?
Yeah. So the biggest probably mistake we've seen is assuming defaults will work for every situation, right? And it's a default for a reason because it's meant to be easy to get started, but it's not necessarily the most secure and the most optimal configuration for everything, right? But people maybe like have become so trusting of Kubernetes that they'll just download the default and put it in production without any tuning, without looking at anything, and then saying, oh, it's not scaling. Well, because you limited the pod to the default CPU or memory, and of course, that's not going to scale unless you have the systems in place to measure that and tune that for your system, right? So Kyverno is very configurable like any Kubernetes controller. Everything can be tuned. All features that you don't need can be turned off. So it does take a little bit of effort and time, right? And, but especially if you just install the stock default, unless you have systems like Nirmata and other things which give you that visibility, that insights, and can auto tune some of this for you at scale. You need to do that work too, right? So don't assume the defaults are just going to work for every situation.
Yeah. So sometimes people trust default too much. Moving to the third question, I know like specifically in the CNCF ecosystem, it is like already very heavy, and we see like new and new projects keep on coming. What are one or two, the emerging project which might not be, that much popular right now, but you think are going to scale very well in the upcoming years?
There were several projects on the whole AI engineering front, which we're tracking very closely, and we'll be also kind of participating in those communities and doing more work with them. There's different layers, of course, but one which stands out, which I find very interesting, is a project called Agent Substrate. And what it does is it takes a different approach to looking at how agents run and what work they're performing. So in Kubernetes, the typical, unit of work is a pod, right? So anytime you want to deploy an application, you create a pod. But with agents, the unit of work is a conversation or a message, right? It's a request response. So what Agent Substrate does is it uses an, again, a deterministic stable execution layer where you have like your executor pods, but then it creates a system of actors on top where you can take, different requests from users and multiplex them on that infrastructure, the pod layer. So basically, it's decoupling the unit of execution for agents from the unit of execution in Kubernetes and allowing you to get a very high throughput, high density, scalable agentic infrastructure. Now, today, this might not be needed. If you're just starting an agent, you don't need this. But, as engineers, we're always fascinated by scale and by performance and these type of things. So if you're building, a large scale system with agents, this is one project that's taking a very unique and different approach, which makes a lot of sense at scale in Kubernetes.
Oh, no, that's a very interesting project and interesting way to look at the things. Okay. So, Jim, we are towards the end of our session. If there is anything else you want to share it with the users.
No, just, I guess final thoughts are we talked about governance and policy as code, and these topics might seem a bit complex or daunting, but they're not, right? They're designed to make your life, as a developer, as an application team, or even as a platform engineer, more productive, more, better, right? So certainly, if you haven't tried Kyverno, go to kyverno.io and download it, try it out. There's many new things coming. Kyverno is now not just for Kubernetes, but like we talked about, for any layer in your application stack, including AI. If you're building AI systems or using AI for coding, certainly check out AI Controls, and would love to hear back from the community and the audience on their thoughts.
Oh, you are right. And sometimes we think like, hey, this policy, this setup seems, very boring stuff. Developers might not primarily prefer it, but that's the right thing to do because specifically with the AI, there is lots more into the stake, right? So you are sending your data, you are sending your day-to-day work. So this is where it really becomes important that you are able to trace it back. Hey, what are the issues? What are something? Because you don't know sometime if there is like someone in between doing some sniffing or something. That is something also. And if there is any change, you just imagine because earlier the AI used to be more kind of a playground, but now it is in everybody's hand, everybody's using it, and specifically with the production use cases. So I consider this as important one, and specifically given how the enterprises are also adopting AI in general.
Absolutely. No, that's a great way to framing and perspective, and certainly appreciate your insights on that.
That's it for this episode of Techie Talks with Kuldeep. Until next time, keep learning and keep innovating. Thank you for watching.